Alright, so we're going to start the chapter 1 and 2 part of the final review. Each of these videos is designed to help you prepare for the final next week. So I would suggest to watch each of these videos at least once after class. So the first three are simple linear equations. The trick to these is just remembering your opposites in terms of operations. So for the first one, what do we have to do to solve for b? We're just going to add 2 to each side. Now, although these are simpler, you want to make sure that you avoid rushing through these types of problems where you make easy mistakes. Because there will be, it is multiple choice, and there will be questions that are designed to test you in terms of, did you remember your signs correctly? Did you rush? And if you rushed, you might have made a simple mistake, but that is, point off, of course. So we have negative 17 equals b. We can use our symmetric property to rewrite this as b equals negative 17. How can you check this? Plug it back in. Okay, same thing for number 2. We're simply going to add 35 to each side, and we get y equals 54. I've mentioned this before, and I'm going to mention it again. The biggest problem I see with people getting these simpler ones wrong is that they try to do all of the operations, especially when there are multiple operations in one line. You want to make sure that you have it step by step. This is step 1. These are just one single step equations. But when we get to multiple steps, keep them separated. Here, what do we have to do to get k by itself? Multiply by negative 8. What's that called? The reciprocal, right. So you have 80, and of course, you can double check. Do you have any questions on those simple single-step equations? All right. If you're watching this video, do check out my teacher website for the entire review ahead of time if you want to work on them before I get to them in class. I'll post that during my second period today, and it's the 17th today. Okay, so now we're getting to multi-step equations and solving those. Same thing, we're just doing more than one step. 6a minus 13a is what? Negative 7a. Remember your sign. Negative 7a plus 5 equals 26. Again, notice I'm keeping things separated line by line. So what do I do now? Subtract 5. Subtract 5, separate that, and I end up with 7a equals 21. Use your division property of equality. Sorry, negative 7. Use your division property of equality, and you get a equals negative 3. All right. Next one. What property will I use to get rid of that 4? Distributive. There are a couple things you could do. You could either divide by the 4, both sides by 4, or you could distribute. You have a couple choices. Since this is a product between 4 and what's in the parentheses, you can just divide and then solve for z. Or you can distribute the 4. So if 8c plus 20 equals negative 28. So when I subtract 20 from each side, I get 8c equals negative 48. So c equals what? Negative 6. Negative 6. Okay. Any questions so far about linear equations, multi-step linear equations? Okay, number 6. Remember, with linear equations, you can really start anywhere you want to. The goal being to isolate the variable or get the variable by itself. So on number 6, what's one thing we could do to start? We could do what? Yes. Add 2 on both sides. All right, so that's what I'm going to do. I'm going to add 2 to both sides. When I do that, I get 3x equals 5x plus 4. Okay? now what do? Yes. Right, subtract 5x from both sides, and you get negative 2x equals 4, so x equals negative 2. Of course, plug it back in to check and make sure you have the correct answer. And I would, before turning in your final, go back in and double check your answers. Plug them back in, make sure they make sense, and if they don't make sense, you know, figure out, if you can, what step you messed up on. What did you say?
How many questions are there?
I believe there are 100. It's a 2-hour question, or 2-hour final. 2-hour final. Okay. There are 55 questions on this review. All right. Let's clear these annotations. Start on the next one. Okay. So now we're entering absolute value territory. What is absolute value? The definition. Yes. Yeah, the distance, the number is from 0. Keep in mind that's when we're looking at, for example, say the absolute value of 6 and the absolute value of negative 6. Those are both 6 units away from 0. We're going to be looking at a word problem in a few slides that's going to ask us to set a minimum and maximum with an absolute value. So do pay attention to that one. That one is relatively new concept. Okay, so number 7. How do I tackle that? What's the first thing that I do? Not subtract 9. Divide by 9. Right. Get rid of everything around the absolute value first. I'll say that again. Get rid of everything around the absolute value first before you split it up into 2 linear equations. So the very first thing I want to do is divide by 9. So I'm going to do that. Divide by 9. Divide by 9. When I do that, I get absolute value 4x plus 5 is equal to what? 2. Now, what do I do? Yes. I separate them into 2. I have 2 equations. I generate 2 equations. One of them being what? Yeah, 4x plus 5 equals 2, and 4x plus 5 equals negative 2. Okay, so do take notes on this one, especially if you have a little bit of a wrong idea about it. It's just a matter of reminding ourselves, okay? So we're going to subtract 5 and subtract 5. We have 4x equals what? Negative 3 for one of them. And when I divide by 4, what do I get for the value x? Yeah, negative 3/4. Check that and make sure that it works. So when we divide it by 9, we have 4x plus 5, the absolute value of that, equals 2. Well, when I plug in negative 3/4, 4 times negative 3/4 is negative 12/4, which is just negative 3, right? Get that? Negative 3 plus 5 is 2, and the absolute value of 2 is 2, so that works. You may not always get a very nice number. That's okay. That doesn't mean you did it wrong. It's a matter of checking to see if it makes sense. Okay, in this side, I'm going to subtract 5 and subtract 5, and I get 4x equals negative 7. Same thing, divide by 4, divide by 4. You have x equals negative 7/4. Again, plug that in and see if it makes sense. Negative 7/4 times 4 is negative 7, plus 5 is negative 2, and the absolute value of negative 2 is positive 2, so that also works. If it doesn't work, what type of solution is that? It's called extraneous, right? Do you have any questions about this absolute value problem before we move on. Any questions about anything so far? Okay. Here we run into the first of several word problems that we're going to see on this review. This says the admission fee to an amusement park is $25. It costs an additional $D to rent a locker to hold your belongings. So that's based on the number of people or the number of lockers that we rent. The total cost for 3 people to enter the amusement park and each rent a locker, so each one of those people rents a locker, is $81. How much does it cost for one person to rent a locker? How will I go about setting this up? What's some important information in that word problem, first of all? $25 is the standard fee to enter the amusement park. So for 3 people, how much is that? $75. So we already know that we have $75 plus something is going to equal the $81. What else is important in that word problem? That it costs an additional $D to rent a locker? It costs $D. We don't know how much, right? Per locker, that's what we're trying to find. We're trying to find that unit rate. How much does it cost per locker? We know how many people are renting lockers. 3. So 3 people times the price per locker, right? Could you come up with that on your own? And if not, what is causing some issues? Anything? Okay, so from here, what do? Yeah, we're going to subtract 75 and subtract 75. So we have 3D equals what? 6. So what's my unit rate? 2. So interpret that. What does that mean? D equals 2. Yes. It costs $2 to rent a locker. Right. So it's $2 per one locker. That's my unit rate. Do you have any questions on that? Alright, so we're back. We are going to solve this equation. It's an absolute value, so we do have to check and see if there are extraneous solutions. The rule is if you have an absolute value set equal to something, you will have to check and see if there are extraneous solutions or not. With inequalities, you don't have to do that, but with equal signs, you definitely do. So in this case, based on the last problem, how do I set this up before I even graph it in order to solve for the value in C? What do I do? I make 2. What are the 2? D over 2 equals 3, and D over 2 equals negative 3. This one's quite easy to check. So what do? Multiply by 2. Thank you for the specifics. Z equals 6. And then, of course, plug that in. 6 divided by 2 is 3. Absolute value of 3 is 3. Multiply both sides by 2 here. Z equals negative 6. Negative 6 divided by 2 is negative 3. The absolute value of negative 3 is also positive 3. In this case, they just want you to just graph 6 and negative 6. So, 0, 2, 4, 6, negative 2, negative 4, negative 6. Simply plot those points. Any questions on that? Alright, the next problem is something that they didn't want us to do when we were teaching the section, but for some reason it's on the final. I don't quite understand that, but yeah, we'll go with it. So this next problem is a little bit new to us. As I mentioned before, this is something that they had to skip during the chapter, but for some reason they're going to put it on the final. That's okay though. It says, in a speech class, students must give a final speech for their exam. The speech can be 15 minutes or within that time by 1 minute. Write an absolute value equation that represents the minimum and maximum length of the final speech. Here's how you would approach this. You want to think about the minimum and maximum times. So anytime you think about something that talks about the minimum and maximum and absolute value, you want to go ahead and write down what those minimum and maximum values are. So we know that you can have a speech that's exactly 15 minutes. What's the lowest time that you can have? Yes. 14 minutes. It could be within 1 minute of that. 14 minutes. And what's the maximum? Yes. 16 minutes. That would mean that 15 is our halfway point. Is our max, 14 is our minimum. So, 14 and 16 have to be solutions to our absolute value equation. In other words, when I solve an absolute value equation, I need to be able to have 14 and 16 as solutions. So these are also solutions to our absolute value equation. So, this is what I mean by that. You have to set up an absolute value equation that will give you 14 and 16 when you do an operation. So, this is what they came up with as a solution, and we'll talk about it. 15 is that amount of time that our speech can be, that's a halfway point between our minimum and maximum. This is our halfway point. The 1 minute is between the 14 and the 16, right? One minute between 14 and 16. Why does this work? Well, if we set up both of our absolute value equations, according to our definition of absolute value, how will we set this up as two equations? T minus 15 equals what? 1. And T minus 15 equals negative 1. Well, what happens when I add 15 here? T equals what? 16, right? What happens when I add 15 here? T equals what? 14. So in both cases, I get what's needed to be my solutions. Does that kind of make sense? So when you see a problem like this on your final, this is what you need to do. You need to list your minimum and maximum, just like Allie did in the beginning. 14, 16. Look through the answers for multiple choice. Go through them and split up your absolute values into two equations, one with a negative and one with a positive, and see if you get the minimum and maximum. If you do, then that's the correct solution. Does that make sense? Yeah? Okay. So again, here with this one, minimum, maximum, go through the absolute values, solve them, where your solutions are the minimum and the maximum, and that's your correct answer. If you get something that's not the minimum or maximum, then that's not the correct absolute value equation to use. Yeah? All right. (13 through 15). are, well, sorry, 11 through 13. 11 is still chapter 1 stuff. 12 and 13, that's when we start to enter chapter 2 territory. So, for number 11, what do I do to solve divide x? Yeah, subtract 6x from both sides. I get 12 equals negative 4x. So x equals negative 3. Does that work when I plug in negative 3 for x? Negative 18 plus 12, does that equal negative 6? No. Okay. Number 12. Okay, this is something that we had some issues with in chapter 5 when we were doing shading, and we had word problems. So you want to make sure that you have a strong foundation of the basics here, even if you know what greater than is. It says, write the sentence as an inequality. A number y plus 4.9 is greater than 29. So how will I write that? Yeah, like that. Now what if I said at most? If I said at most, what would that look like? So if I said y plus 4.9 is at most 29, what does that mean? Yes. Yes. That means it can be 29 or less, right? What if I said y plus 4.9 is at least 29? What would that look like? Y plus 4.9. Yes. Yeah, is at least 29. So the blue, we have y plus 4.9 is at least 29. So it's 29 or more. The purple, we have y plus 4.9 is greater than 29. So it's 30, 31. In the red, we have y plus 4.9 is at most 29. So it's 29 or less. Okay, so make sure you know those words and what they mean. Graph the inequality. This is an open, closed circle step. So is this going to be an open or closed circle? Closed. Remember, if we're dealing with less than or equal to or greater than or equal to, it is a closed circle. So in this case, we're just going to graph negative 7, negative 6, negative 5, negative 8, negative 9. You know it's going to be a closed circle, so you can either back it above or right on that line. And then the trick is, you don't just intuitively know, just draw a little arrow, and it tells you which direction to go. Okay? So it's saying go this way. Okay? And is anything less than or equal to negative 7? Questions? All right. This next problem says the graph shows the age restrictions A in years for 2 clubs at a community center. Write an inequality that represents the age restriction of each club. So first one's club 1, of course. So what they're asking us to do is take a graph and interpret that algebraically. So how am I going to set this up? Yes. Would it be less than or equal to? Yes. It's greater than or equal to. Right. 6. Keep in mind, 6 and anything above 6 is filled in. So that's why A, the value of A, can be 6 or greater. 6, 7, 8, 9, 10, 11, 12, etc. That's for club 1. What about club 2? So we start with A. And what about A? Yeah, it's less than 61. We know it's less than because it's an open circle. And the shading is happening on all the values less than that 61 in the middle of 60 and 62. Any questions? All right. Hopefully this is pretty easy so far, with the exception of the new one. So for this, what do we do? Yes. Yeah, subtract 7.4 on both sides. When you subtract 7.4 on both sides, you end up with 9.5 is less than k. And then, of course, how am I going to rewrite this? Yes. K is greater than 9.5. Now, this has nothing to do with the flipping that's involved with dividing or multiplying by a negative, right? This is just rearranging so that my k starts to the left. Remember, we go from left to right with mathematics. So I'm going to start 9.5, and k is going to be greater than that. 9.5, 10.5, 11.5, etc. Is that going to be an open or closed circle? Open. Of course, you can tell yourself k has to be greater than 9.5. What's that going to look like? Or just simply draw an arrow for a quick and easy little way to remember your direction. Okay. Do you have any questions? Next slide. All right. We have several more. All right, so back up here. How will I solve number 16? Yes. Divide by 15. Do I have to flip the sign? No. Yeah. Just because there's a negative, remember you do not have to flip the sign. It depends on where the negative is. If the negative is in front of our variable, or if it's being divided by a negative, our variable is, then we flip the sign, but we don't here in this case. So we get k is greater than or equal to what? Negative 10. So again, have your graph reflect that. So you can start anywhere here. Negative 10, negative 9, negative 8, negative 11, negative 12. K is greater than. Is it greater than or equal to? Is that going to be open or closed? Closed. So your little arrow there. It's going to go that way. Okay. What about 17? Yes. What happens when I divide by the negative 4? I flip the inequality sign. So Z is now greater than or equal to what? 7. Again, 7, 8, 9, 6, 5. Open or closed? Closed. And a little arrow. Go that way. Okay. What property am I using on number 18? Distributive property. 15 is less than or equal to 5r minus 15. Add 15 to both sides. 30 is less than or equal to 5r. So 6 is less than or equal to r, and then I have to rewrite that. So my final answer is r is greater than or equal to 6. I'm just doing some rearranging, so my variable comes first because I read from left to right. Open or closed? Closed. And then I know that it's going to be pointing that way. well. Questions on any of these three? We have two more, and we'll be done. Okay, 19 and 20. Okay, on number 19, what do I do? Yeah, add 8 to both. So the difference here is I have an operation in between my variable, or attached to my variable, I should say. So I add 8 to both sides. For some reason, the district gave us this study guide and they didn't label this graph correctly, but that's okay. So we have 4 is less than x is less than 8. Is this an and or an or? Do you remember? It's an and because it's together. So what we really have is we have x is greater than 4 and x is less than 8. So I'm going to look, I have both open circles. 4 is here, 8 somewhere over here. And then I have to think about the shading. Do I go towards, do they meet in the middle or do they go opposite directions? They meet in the middle, right. X is greater than 4, so it's all of these, but it's also less than 8. So ands will always meet in the middle. Questions about that? All right, last one for today. Distributive property, 7w plus 70 is less than or equal to 7w plus 63. What's going to happen to my 7w's? They're going to cancel out. If I subtract 7w and subtract 7w, I'm going to end up with 70 is less than or equal to 63. How do I know if it's infinitely many solutions or no solution? Is that infinitely many or no? Yeah, how did you know? Yeah, it's not a true mathematical statement, so it's no solution. Okay, that's your first 20 questions of your review. We have, like I said, 55 to get through this week. We will get done, and I anticipate that we'll have one last day to ask any questions that you may have and go over anything. So, take a look at this video tonight one more time, and that'll be it.